Hi guys, so welcome to our Wix DBA meetup. Really glad to have you here. My name is Lior Altarescu. I'm a part from a DBA team. Currently, tonight it's going to be me and Baul. There's Baruch sitting over there. Showing you a bit about a couple of new features we're talking about, we're investigating. So today, I'm going to talk to you about working with NoSQL in an SQL database. Now, when thinking about what to talk in this meetup, me and my teammates, we were thinking how we work with developers. Now, here in Wix, there's over 1,500 developers and only 40 DBAs. So the ratio is not really in our favors. So we were thinking how we can help them develop a bit faster, let them be a bit more independent from having to talk to us all the time, having to discuss with us different architectures, different objects they want to create. And we stumbled a bit around the web, and we saw this new feature that Oracle came out with, EXIF API. And I'm hoping to share this feature with you and share our ideas on this feature with you guys that you could take back with you, So, again, my name is Lior Altarescu, DBA for 7 years, and I've been working here at Wix for over a year. Now, besides the fun and games, sometimes we'd like to have Nerf gun fights at the office, sometimes a bit of we're going to have a happy hour. Whenever we want to introduce a new technology here in Wix, we really need to have to do our homework, because we have a massive scale. We have over 1,000 database servers spread across multiple regions, and everything needs to work flawlessly. So one of the reasons that I'm able to talk to you here is because we studied this feature, and we want to share our knowledge. We want to share our findings, what we think about, a bit about our problems, and basic knowledge of it. So we're going to talk about what exactly is EXIF API, what the feature is. We're going to show how the architecture works with this feature, how the architecture in the MySQL looks like. We're going to show a couple of examples of how to use it with CRUD operation. And lastly, we're going to show our experience with this feature, the problems that we had facing, how we're thinking of implementing this feature here in Wix. So let's begin. So usually here at Wix, there isn't a lot of complexity in the queries. Most of the developers here just want to save their data, store it, take it out. There isn't a lot of need for joins. Most people like to work in an unstructured way and just basically keep their data in the JSON data type. Now, Wix is a pretty big site. There's over 130 million. I'm guessing even more than that by now. And as I said before, it's spread around the globe. Sorry. Now, usually, when a developer comes to talk to us, a developer that's working on a microservice or a different kind of application, he'll usually want to work with an unstructured data, showing a bit about how that JSON data type works and is associated to the application. Now, most of the MySQLs here at Wix are relational. So usually when the developer comes and shows us the unstructured data that he wants to work with, he'll show us something like this. And because here at Wix, most of the databases are relational, and we're working with mostly MySQLs, in my mind, I'm thinking how to take this JSON and turn it into something like this. So on the one hand, the developer wants to work in a non-SQL way and help him boost his development, make it a bit faster, even work without SQL. And on the other hand, I want to maintain all the advantages of the relational database. So we were thinking what can do this? How can we achieve both working in a non-SQL way and in a SQL way? MySQL solve this, and we're going to talk a bit about how it does that. Any questions? No. So what exactly is Xdiv API? Basically, Xdiv API is a high-level database API that wraps underneath them a couple of other APIs and allows us to work in a schemaless fashion. No need to create tables, no need to create other database objects. You just use the native client language you're working on to interact and to work with the database itself. Now, the new drivers that support the Xdiv API, despite the previous drivers, the MySQL connectors that are synchronous, the new drivers are not, they are asynchronous, and they support CRUD operations. Now, they are asynchronous. They utilize this by using callbacks and promises, and they come in multiple native languages, such as listed here. Here at Wix, we mostly use Java and Node.js, so it's really convenient for us. Now, we could also use the Xdiv API and use the subset of it, the session API, to transparently scale the MySQL from one server to multiple servers in our environment, which is really nice because if we would have wanted to do it on a regular basis, not using the Xdiv API, I would have had to create another server and connect it by hand or by an automation. This Xdiv API envelops this feature, which is a part of also the new features. Now, the Xdiv API, basically, the way it let us work in a schemaless fashion is that it utilizes the document store. The document store is an abstraction over the JSON data types that lets us work like that. Really nice thing about it is that it maps the client's data structures to the database data object. So a couple of its key features is that because it works with the JSON data type, it's schemaless. You don't have to create a new table or a new schema. You can work in a fully NoSQL way. Now, because we're using the MySQL database, it keeps all its relational abilities and advantages, so it's fully ACID. Also, it keeps data integrity. It supports transactions and locking. Now, each document that you create, and I'll explain in a bit exactly what's the connection to documents, it could be up to 1 giga. Now, whenever we work with the Xdiv API, it enables SSL and TLS from the start. So security is not really something that you need to worry about. Also supports GTID replication and transaction isolation. So the way that the document store works, it utilizes documents and collection. Now, collection could be one or more documents. And in the background of the MySQL itself, the way it works is whenever you create a new collection, a table is created, which is comprised out of 2 columns. One is a unique ID, and the second is a JSON data type column. That each row in this table is a document. Now, again, you can store in each row up to 1 giga, which is really, really nice. And that's exactly how it works in the background. So if we want to look a bit how it works in the background, basically, we have a regular connector. This currently is not a connector that supports the Xdiv API. It connects directly to the port 3306. Now, in order to work with the Xdiv API, we install the X plugin, which allows us to work with the new X protocol. And we use the new connectors that support Xdiv API to connect to the MySQL database in another port, 33060, and work in a non-SQL Xdiv API fashion. Another really nice feature that Oracle introduced is the X protocol, which, by the way, is open source, and it's based on Google Protobuffer. I don't know if anybody heard of it, but it's an open source project that you can take and you can expand by yourself if you want to add other commands to work with. Okay. So let's take a couple of examples how to work with Exif API. Now, let's say I want to create a new collection. Then I would have used the DB API and the command create collection to create a new collection. If I want to get the collection and change it, all the examples, by the way, all the examples that you see here are being done on MySQL shell in a JavaScript option. There's a couple of options to work in the MySQL shell, also SQL and Python. Here we can see if we want to take the collection, you could also put it in another variable, go over it, change it however you want. We can also drop it. Here's an example that you drop it and you can see that the collection itself is dropped. Now, let's say I want to insert a new document. Here I try to show the equivalent of running the SQL command as opposed to inserting it with the Exif API. Now, if I would have want to use the Exif API command, I could add a new document in the collection itself. Here, I append another add command, and I could append a lot of other documents and insert it all together. I could also do two different commands. If I would have done it in an SQL fashion, I would have run just two separate inserts to insert the equivalent columns. Now, let's say I want to query. Let's say I want to query all the documents that the price is over 25,000. So what I would have done is what I've used a find, which is also part of the DB API, and I would have run in the find the where clause, where I would have used in the select. Now the second option is using placeholder binders. The placeholder binders is a better way to use with the Exif API because whenever we run it, an execution plan is created and we can change, if we want to run it again, we can change the parameters and it'll be faster next time it's running because it utilizes the execution plan from the previous run. So that's an advantage. Let's say we want to update a document, we want to change an attribute in the document. If I would have wanted to do it in an SQL fashion, I would have used a simple update command where I set the price and with a where clause. But with the Exif API, I would use modify with a column, like name equals phone, and set to change the appropriate attribute. Now, also here, I could have used bind placeholders to work with. And change a query, I could have run multiple modify commands. If I want to if I want to update multiple documents. Now, here's an example of how I can delete a row or just delete a document from the collection itself. The collection, the Exif API also allows us to work in SQL fashion. If we want, we can run also raw SQL if we need to, which is another big advantage using the Exif API. Guys, any questions till now? Do you want me to elaborate on something? Cool. So, now, I said before that it also is fully asset. And a part of it is that it supports transactions, like a regular transactions log that we would have done under MySQL. Here's an example of how I start a transaction, set a save point, add a couple of documents, roll back to it, and in the end, I commit. And this is equivalent to a regular MySQL transaction block that I can work with. Now, let's talk a bit about MySQLs at Wix, what we currently have right now. So, currently, all of our MySQLs are Community Edition. We don't have currently any Enterprise at all. We're using 5.7 MySQLs, and we're planning on migrating them. Will probably be in the near future. Now, all of our MySQLs are on either AWS Cloud or on Google Cloud, and they're spread on multiple data centers, multiple different regions. And beside of that, we're using Orchestrator to manage our application. If you don't know what Orchestrator is, so it's an open source tool that you can use to manage different replications and also monitor with it. Now, this is a schematic of a basic MySQL cluster that we have here in Wix. It's usually spread between two different DCs. Now, the blue boxes at the top are the application servers, and each of our application servers talk to a proxy SQL. We love proxy SQL. It has a lot of advantages that we're very happy of using it here. It also supports it also has high availability, load balancing between read connections, and also failover for write connections if the primary MySQL that's open to writes failed and it moves to another one. The proxy SQL will automatically redirect the write connections to the appropriate MySQL. And the proxy SQL is aware of all the nodes in the cluster, meaning if we have different MySQLs in different regions across the world, the proxy SQL is aware of that, and if there's no MySQL available in the current region, it will transfer you to another MySQL that's available, the nearest one available. And beside of that, we also have a couple of internal tools that we use for failover and monitoring. Now, each of our MySQLs could have one of a couple of roles. The most of them support user traffic. Some of them are for internal use, such as BI, developer access, or backups. Now, as I said before, we really like proxy SQL, and currently proxy SQL does not support X protocol, which is pretty unfortunate, and that's what we need. And that's what we need in order to use the XF API. Now, going a bit back, one of our regular use cases that we have here at Wix is that we, on a weekly to monthly basis, need to switch over our traffic between one DC to another. So basically, we have an automated task that goes over all of our MySQLs, checks to see which nodes are healthy on the appropriate DCs, and fails them over. Now, the way it does that is that we have between our two main data centers, they're configured in a master-master application where only one of them is open to writes, and the second one is only read-only. Now, when we need to switch over, we would close the one that's read-write and open the one that's read-only. The reason that we do this is because it's really, really fast when we need to fail over, when we need to switch over our traffic. Some of you might be asking, why not use regular MySQL replication? Well, the answer for that is that if we would have done that, we would need to promote, and that could take between 30 seconds to 1 minute, which is quite a lot for us. So we prefer to do it this way and configure it like that. Now, one of the problems that we're facing here is that proxy SQL does not support X protocol, and it currently doesn't plan to support X protocol, unfortunately. So basically, we're thinking that we need to find a way to substitute the proxy layer. We need to find something that will give us all the advantages that Proxy SQL gives us, and also support the X protocol, which will allow us to work with Xdev API. So how can we do that? We were thinking and thinking, and we took a look at the new connectors, at the new MySQL connectors. If you haven't looked at them, they started to resemble a bit the Mongo drivers, which you can give them a list of hosts, and also some of them know how to failover and load balance. So we were thinking, OK, let's look at that. Maybe we can use the connectors and eliminate the Proxy SQL at all and use that. So here at Wix, we usually code in, the applications here are coded usually in Java and Node. Now, the Java connector is really mature. It supports also multiple hosts. It supports smart failover and load balancing for read queries. But on the other hand, the Node.js is not as mature as the Proxy SQL, as the Java connector, sorry. Although it does support the failover, it does not support load balancing, which is pretty important for us, because most of our traffic is read traffic, and that's something that we can't compromise on. Also about the failover for the Node.js connector, it's pretty primitive and not as mature as the Java one. So we are waiting to see where it continues. Now, let's say in the near future, the connectors would work and they support everything we need. So if we utilize the Java connector and the Node.js connector, we could eliminate the Proxy SQL, and our architecture would look something like that, where we eliminate the Proxy SQL at all, and we connect directly from the application servers to the MySQLs directly, with not needing to change anything except the connector itself. So one option is that we just wait and see what happens, and hopefully in the really near future, the connectors will support it, and the only thing we'll need to do is change the connectors, and that's it. It will save me a lot of work. So that's one option that we thought about. The second option is a bit more complicated, and in order to explain it a bit more, we'll need to talk about two things. One of them is InnoDB cluster, and the second one is the MySQL router. Now, InnoDB cluster is a new high availability solution that Oracle came out with. It has really a lot of nice features. It gives you high availability out of the box. You don't need to use any additional infrastructure or scripts in order to fail over the MySQL cluster to another node. It does it automatically. Besides that, you could also work with Xdev API and Admin API, which allows you to work in an administrative way with InnoDB cluster, and you could also use it to scale the InnoDB cluster to more servers, adds more servers for read queries, which is really nice. And about MySQL router is a lightweight middleware that basically allows for routing purposes, for routing connections, and it does support Xdev API. Now, basically, maybe some of you are thinking, OK, so isn't the MySQL router the same as Proxy SQL? Well, not exactly. The Proxy SQL has a couple of more capabilities that are a bit better than the MySQL router. But the MySQL router does support the Xdev API, which is currently what we're talking about. So we can also use to incorporate the InnoDB cluster with the MySQL router, and it gives us basically a high availability solution for the InnoDB cluster. One of the appropriate ways to work with with a MySQL router is that you also have another one on the application app, that the application connects to the local MySQL router and talks to the MySQL cluster, application, InnoDB, whatever. So why not use InnoDB cluster? Let's throw away the MySQL application and use MySQL cluster. Well, although it does support high availability, it's really easy to administer, easy to scale. In order to do all those stuff in MySQL replication, you do need to have a bit more additional infrastructure, such as an orchestrator or cluster control or scripts or administrative tasks that you've written. It's a bit harder to maintain because it's not done all automatically. Also with scaling, but the InnoDB cluster is still a bit mature. Hopefully, in the really near future, it'll be a more reliable solution that we can use and incorporate here. But right now, it's still pretty new. I've got my eye on it, and hopefully, it will only improve. Now, about the second solution, basically, here's a schematic of InnoDB cluster with MySQL router. Now, let me explain exactly what you're seeing. The boxes at the top are application servers incorporated with MySQL routers. Each one of the circles are InnoDB clusters with MySQL router. The reason for that is that the InnoDB cluster, together with the MySQL router, allows the high availability for connections to continue, such as if one of the nodes fails and another one will take its place, the MySQL router will reroute to the node that took its place. And the MySQL routers in the servers, in the application servers, connect to the MySQL routers in the InnoDB cluster. Now, this solution is taking into account that some of the client drivers do not support Exif API. So that's why it looks like this. If we would have worked only with Java, again, we could eliminate the MySQL routers. But for the InnoDB, for the Node.js applications, and also the C++ that do not support the load balancing, this is an ideal solution. And also for our use case here, for us use case here in Wix, we have an asynchronous replication between the two DCs. That way, if we need to switch over traffic between DC1 and DC2, it's easy as shutting on DC1 the option for writes and opening it on DC2. And that's how we can still maintain our ability to switch over while having also local promote and working with Exif API. Not taking into the fact that the Node.js currently does not support the Exif API. Okay, so let's review a bit what we talked about. Exif API is basically a high-level database API that allows you to work in a non-SQL way with database objects, also non-relational and relational. Currently, Proxy SQL does not support Exif API. Hopefully, maybe in the future, it will. So I've been Lior Altarescu. Thank you very much for listening on the talk.